solution to question 1, we must know that this function is the same as e to power ln of this. These two expressions, they are what? They are equivalent. So this is what we are going to be using. So we are going to solve this one. At the end of the day, when we get the answer, we'll put it there. Then limits as x tend to 0 positive will be equal to limits x tend to 0 positive. If you apply your logarithm rule, that will be ln 1 plus 2x all over x. Next thing to do now, direct substitution, you have what? Is what? Indeterminate. And in that case now, when you have 0 over 0 or infinity over infinity, then you apply L'Hopital rule. In L'Hopital rule, you are going to differentiate the numerator, differentiate the denominator individually. So for this one, for numerator, we're going to have 1 over the inner function of 2x times the derivative of that inner function times 2 all over the derivative of what? Of the denominator. That's what? That's 1. Okay, then you can do your direct substitution. So if you do your direct substitution, it's going to give you 2. So finally, your function, your question is equal to what? Is equal to e to power what? E to power 2. And that finished that question. The B part, determine whether or not the function f of x is continuous at x equal to 0. So what we're going to do is to look at the boundary condition we are given. This is x is greater than or equal to 0. This is x less than 0. Determine continuity. Okay, the first thing we must know, the condition is this: limits of f of x as x tends to a positive must equal to limits of f of x as x tends to a negative. They must be equal to each other, and at the same time they must be equal to what? F of what? F of a. And our a in this question is what? Is 0. So that means x greater than 0 is going to be the right hand side. X less than 0 is going to be the left hand side of the what? Of the limits. So we now have now limits as x tends to 0 positive. That's the right hand side. Okay. The function we have there is what? Ln x plus 1. Then you do your direct substitution. So if you do that, you're going to have what? 0. You can also do the left hand side of that function. Do your direct substitution. If you do that, you're going to have to be e to power 0. That's 1. That's 3 times 1 minus 3 minus what? Minus 0 all over what? This will give you what? 0. Okay, so this will be 0 over 0, indeterminate. When you have indeterminate of either 0 over 0 or infinity over infinity, then you apply L'Hopital rule. So we now have limits as x tends to 0 negative. Differentiate this one, that will be this will be 0 minus 5 all over what? 2x plus 1. Then do your substitution, so that will be 3 minus 5 over what? Over 1. And that's what? Minus what? Minus 2. So we now realize that the limits as x tends to 0 positive is not equal to limits as x tends to 0 negative. The right hand side and the left hand side are not equal. So limits of f of x as x tends to 0 does not exist. Hence, f of x is not continuous at x equal to 0. Okay, please, if you're watching me for the first time and you're yet to subscribe, please click on the watermarks on the video and subscribe. Click on like button and begin to type your comments. Finally, share the links of this video on all your social media platforms. Thank you for doing that.